If you are looking for additional ways to support your child at home, this video will overview how to use the break apart to make 10 strategy for subtraction. Your child will be asked to use this strategy to solve subtraction problems with numbers within 20. We teach this strategy because it helps children to see that larger numbers are composed of smaller numbers, and it helps them to transition from using visual aids to the symbolic level where they will only have an equation to work with. We begin using break apart to make 10 for addition problems and then transition the students to use the strategy for subtraction.
Here is an example of an addition problem using the break apart to make 10 strategy. Here we have 7 plus 5. The 7 is represented here in what we call a tens frame, and the 5 I will represent using our unit cubes. To start solving, we first must complete our tens frame. We move 3 of our unit cubes into the makes 10 circle to show that it needs to be added to the 7 to make a 10. The leftovers of the 5, these 2 cubes, move into the leftover circle to show we have 2 1s in addition to our tens frame. This gets us to our answer, 1 10 and 2 1s, or nicknamed 12.
Here's how we modify the break apart to make 10 strategy for subtraction problems. Because we are working with subtraction problems using numbers within 20, we have 2 tens frames. The tens frames will represent our subtrahend, which in this problem is 15, the number we are subtracting from. And these unit cubes will represent our minuend, which in this problem is 7. This is the number we are subtracting from the subtrahend. In this problem, 15 minus 7, we will decompose our minuend of 7 into 2 parts. The first circle represents the part of 7 that we can subtract from our incomplete tens frame to leave us working with just our complete tens frame. The second circle represents the part of 7 that is left over, which we will then subtract from our 10. In this problem, we decompose 7 into 5 and 2 because there are 5 dots in the incomplete tens frame, which leaves us with 2 unit cubes left over. Then we subtract the leftover unit cubes, which is 2, from 10, leaving us with 8. This strategy can be very useful for students in order to connect the symbolic written equation they are asked to solve to real quantities, as it helps them to visually see the quantities that they are working with. It is important for students to know various subtraction strategies that help them to break down complicated problems into simpler terms. With the break apart to make 10 strategy, it helps students break apart the minuend just as we did in the example problem by decomposing the number 7 into 5 and 2. Subtraction problems using numbers above 10 can be intimidating for students because these larger numbers are less familiar to them, since learning math facts to 10 is an important goal for students. Using this strategy, students can manipulate equations given in number terms within 10 and still arrive at the same answer. This can be helpful in building their subtraction skills and allow them to be comfortable with the increasing difficulty of subtraction problems. This strategy can be used with subtraction problems containing numbers beyond 20 as well, as long as there are enough tens frames for the problem. For example, problems with numbers to 50 would require 5 tens frames. However, it is our goal that with the use of the break apart to make 10 strategy, students gain understanding about the relationships between larger quantities and the numbers within 10, so that with larger quantity equations, like the example of 15 minus 7, students will reach a point where they no longer need to visually see the tens frames and use the unit cubes to break apart the minuend, but will understand how to work with numbers at the symbolic level while keeping this strategy in mind. We hope that this video is helpful to you in your goal of supporting your child at home. Please feel free to contact me for further resources.